Hello, this videotape covers addition of integers. So far we have just been dealing with the natural numbers, that is the positive whole numbers, 1, 2, 3, 4, and so on. It will soon become obvious, however, that the natural numbers will not be enough for all of our purposes. Let's suppose you have $20 in the bank account and you write a check for $10. This would leave you with a balance of $10. On the other hand, if you have $20 in the bank and you write a check for $30, this would leave you with an account that is overdrawn in an amount of $10. You can't simply write $10 in your bank book in both instances. We need some way of indicating, and in one case you owe the money, in one case you have the money in the bank. A nice way of doing this would be to put a plus sign before 10 if it's your balance, and a minus sign before the number 10 if it indicates that your account is overdrawn. We can also do the same thing to indicate temperatures that are above 0 degrees and below 0 degrees. In short, negative numbers provide a nice way of indicating a sense of direction as well as an amount. A good way of visualizing the negative numbers and their relationship to the positive numbers and 0 is to use a number line. Let us put down a line which continues in both directions and put an arrow on this end to indicate that the numbers will be increasing in this direction. We could put over here the number 1, here the number 2, the number 3, 4, and so on. These are your positive whole numbers, and this would continue. The positive whole numbers, your natural numbers. A number 1 unit to the left of 1 will be denoted by 0. The number 1 unit to the left of 0 will be represented by a minus 1, then a minus 2, minus 3, and so on. The positive whole numbers do not have to have any sign before them, but if we want to emphasize that these are the positive numbers, we could prefix these numbers with little plus signs. Now, the positive whole numbers, this set of numbers is called the natural numbers. When you take the positive whole numbers and the negative whole numbers together with 0, the set that we get we call the integers. So far, we know of 2 uses for the minus sign. It can be used to indicate a negative number, for example, minus 4. It can be used to indicate subtraction. You've seen this in arithmetic. 8 minus 5 equals 3. Here, the minus sign is indicating the operation of subtraction. Here, the minus sign right before the number is indicating the negative number. There is also another use of the minus sign. When it is written right before a signed number, it means the opposite of that number. For example, the opposite of the number plus 3. By this I mean minus 3. The opposite of plus 3 is minus 3, or the negative of plus 3 is minus 3. Let's look up here on the number line. Here is the number plus 3. The opposite of plus 3 is minus 3. That is the number on the opposite side of 0 from plus 3, but the same distance away from 0 is the number minus 3. The opposite of plus 3 is minus 3. The opposite, or the negative, of plus 3 is minus 3. And we can also use it the other way. The opposite of minus 3 is plus 3. The opposite of minus 3 is plus 3. The number on the opposite side of 0 from minus 3, but the same distance away from 0 is plus 3. By the way, this idea of 2 negatives resulting in a positive happens a lot in algebra. It's very similar to two negatives resulting in a positive in the English language. Okay, if you're not going to the movies, you could say, I am not going to the movies. Somebody learning English for the first time, if they want to indicate the opposite of that idea, they might say, I am not going to the movies. Of course, once they get better acquainted with the English language, they would say instead, I am going to the movies. I am not going to the movies means the same as I am going to the movies. Over here, the same idea. The negative of -3 is +3. Okay, so we've seen three uses of the minus sign: to indicate a negative number, to indicate the operation of subtraction, and to mean the opposite or the negative of a number. Before we actually formulate our rules for addition of integers, there's one more point I want to get across. You've seen a certain relationship between the numbers. You might have noticed a certain relationship between the numbers +3 and -3. They both happen to be the same distance away from 0. Okay, 3 units away from 0. We also have the same situation with +2 and -2. They are both 2 units away from 0. This idea, okay, the idea of the distance of a number from 0 is given a name. We call it the absolute value of the number. Let's write that down. The absolute value of a number A, which is written A with a line on either side of it like that. The absolute value of a number A, which will be written A with a line on either side of it, represents the distance between the number A and 0 on the number line. Therefore, the absolute value of +7 is equal to +7, or just 7. The absolute value of -5 is equal to +5. And the absolute value of 0 is equal to 0. Let's go over these. The absolute value of +7. +7 would be about over here. The absolute value of +7 represents the distance between 7 and 0, which is 7 units. So that's +7. The absolute value of -5 would be over here on the number line. The absolute value of -5 would be the distance between -5 and 0, which is +5. The absolute value of +5 is also +5. Make sure you understand that. The distance between +5 and 0 is the same as the distance between -5 and 0. Each one of these is 5 units away from 0. The absolute value of +5 is +5 or just 5. The absolute value of -5 is also +5 or just 5. Okay, if a number has no sign before it, it will mean the positive number. If I just write 5, I mean a +5. If I want to indicate a negative number, I have to prefix it with the minus sign. If you see no sign before the number is assumed to be a positive number. The absolute value of 0 is 0. The distance between 0 and itself, of course, is 0. We will now try to formulate a reasonable method for addition of integers. Our basic ground rule, the one thing that we will insist upon is that whatever rule we develop for addition of integers must be consistent with the rules that we already have for addition of natural numbers. Okay, now in natural numbers, 5 plus 3 equals 8. I'm not telling you anything you don't already know. If we want to really spell out the fact, clarify the fact that these are positive numbers, we might write plus 5 and plus 3 gives you plus 8. Okay, but it's really the same 5 plus 3 equals 8 that you're familiar with. Okay, let's look at this addition on the number line. This will be 0, 1, 2, 3, 4, 5, 6, 7, 8. These are all positive numbers. And on the other side, we will put the negative numbers, minus 1, minus 2, minus 3, minus 4, minus 5, 6, 7, and 8. Okay, we can look at this addition on the number line in the following way. Plus 5 and a plus 3. Plus 5, we're starting here at 5, and we're adding 3 to it. We can interpret this as a move 3 units to the right. 1, 1, 2, 3. 1, 2, 3 to plus 8. This is plus 5 adding a plus 3. We're at plus 5, we move to plus 8. Plus 5 and plus 3, 3 units to the right, lands us at 8. Or you could think of this in terms of a bank account. You have $5 in the bank, you put $3 in, you now have $8 in the bank. Okay, now, all the rules we're going to develop for addition of integers, for addition of signed numbers, are going to be consistent with this idea. If I want to consider the problem plus 5 and adding to it a minus 3, if when you add plus 3 to plus 5 you move 3 units to the right, then the only thing that would make sense in this case, if I'm going to add a minus 3, I must be moving 3 units to the left. We're at plus 5 and we're adding a minus 3. We will land here at plus 2. We're at plus 5, we add a minus 3. We move 3 units to the left, landing us here at plus 2. Or you have $5 in the bank and you write a check for $3, leaving you with $2 in the bank. All right, now let's consider adding things to negative numbers. Let's say we have minus 5 and we want to add a plus 3. And we'll also consider the problem minus 5 and we want to add a minus 3. Okay, at minus 5, we want to minus 5 we want to add a plus 3. We start at minus 5. Once again, if we're going to be adding a positive number, we must be moving 3 units, in this case, to the right. We must be moving to the right if we're adding a positive number. So we start at minus 5, we add a plus 3, that is, we move 3 units to the right, landing us here at minus 2. We are adding plus 3 to minus 5, taking us from minus 5 to minus 2. Minus 5 and a plus 3. Minus 5, moving 3 units to the right, lands us at minus 2. Okay, if adding a positive 3 moves us to the right, then adding a negative 3 must be moving us to the left. Minus 5 adding a minus 3 means you start at minus 5, you move 3 units to the left, and it lands us at minus 8. Okay, we're at minus 5, we add a minus 3, which means we move 3 units to the left, landing us here at minus 8. And once again, you can think in terms of a bank book. You have overdrawn your account by $5. You have minus $5 in the bank. You put in $3. You're still overdrawn, not quite as much as you were before. You are now down $2 in your checking account. You were overdrawn 5, you put in 3, you're still overdrawn, but only by $2. Okay? Here you're overdrawn by $5, you write a check for $3, you're now overdrawn by $8. -3 and a -6. Okay? -3 and the -6, we're adding up numbers with the same sign. We block out the sign, we add up the numbers 3 and 6, get 9, and we put the common sign before it. Writing it in the horizontal fashion, we would have -3 and a -6, giving -9. Okay. How about +3 and a -6? Could be also written +3 and a -6. These problems are the same. We are adding them up, and they have different signs. We block out the signs. We subtract the smaller from the larger. When we block out the signs, okay, we subtract 3 from the 6. Remember, the larger number doesn't have to be on top. 3 from 6 gives us 3. Then we look at the larger number 6. It had a minus sign. The answer was negative. You could always, by the way, think of this in terms of a bank balance. You have $3 in the bank. You write a check for $6. You are then overdrawn by an amount of $3. Okay? Or writing it this way, adding them up, different signs. You subtract the 3 from the 6 to get 3. The larger number was 6. It has a minus sign in front of it, so the answer has a minus sign. How about -8 and +8? Okay, different signs. We subtract the smaller from the large, but they're really the same. And 8 from 8 gives you 0, and 0 doesn't need any sign in front of it. It's like you're overdrawn $8. You put in the $8. You wind up with a balance of 0. Okay, we can also mix the absolute value that we mentioned earlier with the signed numbers here. Let's say we want to add the absolute value of -5 and the absolute value of +5. If I just write 5 here, I mean a +5. Now, the absolute value of -5 is the distance between -5 and 0, which of course is +5. And the absolute value of +5 is the distance between +5 and 0, which is also +5. We are now adding numbers with the same sign. We add up the two 5s, giving us 10. We tack on the common sign, the plus sign. Let's look at two problems that look alike, but they're done differently. The absolute value of +3 plus the absolute value of -4, and also the absolute value of +3 and -4 inside the absolute value signs here. Here I have, in other words, the absolute value of +3, and to that I will add the absolute value of -4. On the second problem, however, I first want +3 and -4 added together and the absolute value of the result. Okay? You work out this absolute value, you work out this absolute value, you add up the answers. Here, you work from the inside out. You first do the addition of signed numbers that's called for, and at the end, you take the absolute value. Okay, in the first problem. The absolute value of +3 is the distance between +3 and 0, which is +3, or just 3. The absolute value of -4, the distance between -4 and 0, is +4. +3 and +4 gives you +7. You add up the 3 and the 4, you tack on the common sign. Now look over here. Here, you're first going to do the addition of these two integers, and then you will take the absolute value of the result. You would like to add a +3 and a -4. That is, add numbers with opposite signs. Okay? We block out the signs. We're dealing with 3 and 4. We subtract 3 from 4, and we get an answer of 1. Then we say 4 was the larger of the numbers. It had a minus sign, therefore the answer has a minus sign. The absolute value of -1 is the distance between -1 and 0, which of course is +1. Our rules for addition of signed numbers if we are adding up more than two signed numbers. For example, let's say we want to add -3 and a -5 and a +7. Okay? Remember, you can put parentheses around this one if you feel better about it. There are 3 integers to be added up. Okay, you can add them up. Say you can add the -3 and the -5, get that answer, that subtotal, and then tack on the +7. Okay, -3 and a -5. You're adding numbers with the same sign. Okay, you take the 3 and the 5, you add them up, you get 8. You tack on the common sign, -8. And to that you will add a +7. Now, adding a -8 and a +7 means we are going to be adding numbers with opposite signs. We forget about the signs. We're talking about 7 and 8. We take 7 from 8, we get 1. But the 8 was the larger of the two numbers, and it had a minus sign, so the answer is -1. Let's try one more example. 12 and -3 and +5. This could really be written +12. If the problem said 12 plus -3 plus 5 like this, your first step would be to mentally think of this as +12 and a -3 and a +5. Whereas a number without a sign is a positive number. 12 is really +12. 5 is really +5. The -3, of course, had to be specified. Okay, you can do the same thing we did before, add the 12 and the -3, and then take the result and add the +5. Or you might rearrange the problem. When you're adding positive and negative numbers, it might be easier if you take a step first to put the positive numbers first and then the negative numbers. In other words, regroup this. Okay? Instead of -3 and +5, make it +5 and the -3. Addition is commutative, so we can do this, switching around the order of the addition. Okay, this makes it just a little bit easier because we have a +12 and a +5 giving us a +17. And then we add the -3. And the same thing if I had, say, several negative numbers and several positive numbers. I'd add up all the positives first, all the negatives first, and then get the grand total. +12 and +5, we add up the 12 and the 5, tack on the plus sign for +17. Now we want to add a -3. Here are two numbers we're adding. They have different signs. Okay, we forget about the signs. We're dealing with 3 and 17. 3 from 17 gives you 14. The 17 was a larger number. It had a plus sign, so the answer has a plus sign. And this brings us to the end of the videotape on addition of integers. If you have any questions, you can ask a tutor in the math lab or view the videotape again.